Let's talk about the AC behavior of an NPN transistor. So the way how we draw the small signal model of an NPN transistor, we have the base. We assume that there is the resistor here that we call it R pi. The voltage here I pi. This is your base. And the voltage controlled current source, and the output resistance of the NPN transistor. So here the R pi is actually the definition is the change in the base emitter voltage to the base current. So this is this VBE, we call it V pi, and this value is beta divided by GM. So now we need to talk about GM. GM is the rate of change of the collector current with respect to the base emitter current, base emitter voltage, and this is given as the current versus IC divided by VT. So now we have the R pi, we know the R pi value, so we can also plug that in here with the GM. That makes it B beta times VT over IC. There's another thing that we need to talk about here is your output resistance. So output resistance of a transistor comes from the fact that when we write our current equation, this is the simple version, and if you look at here, the collector current is not a function of collector emitter voltage VCE. It's only a function of VBE. But in reality, we also have a term here that makes the collector current a function of the collector emitter voltage. And here this VA is called the early voltage. It's just a definition. So therefore your output resistance here is defined as the collector emitter voltage change with the current change, and this is given as VA over IC. So now we have the output resistance, we have the GM, and we have the R pi, and this is our model.